Okay, today we are doing P3, which is radicals and rational exponents. This is our first day. And your learning goal, don't forget to write this down, is that you will be able to evaluate, simplify, and add and subtract square roots. So with this section, you're going to really need to know your perfect squares because that's going to come in handy. It's a very good practice to make sure you go over all your perfect squares because you're going to have to simplify them. For example, you may have to simplify the square root of 27, which means that's square root of 9 times the square root of 3. And your answer would be 3 square root of 3. So that's what I mean by simplifying them. And sometimes you may get something like this, where you would have to multiply them first before you simplify it. Okay, so 80, square root of 80, is the square root of 16 times the square root of 5. And then, of course, you have that x squared. So the square root of 16 is 4. The square root of x squared is just x. And then the 5 stays under the square root. And we can do that because we're assuming that the variables are non-negative real numbers. So, because if they ask you to square root a negative, like this, you cannot get a real number. So if they say, indicate if it's not a real number, you'll just say, not real number. Okay? And the same works for division. Sometimes the fraction will be a perfect square, like this, which will be 1 over 7. So the numerator and denominator are both perfect squares. Sometimes you have to square root it first, or divide it first, I should say. So if you had something like this, I always put it under 1 so I can divide them. Because you never know, you might, with like this one, get a perfect square. Don't forget with the variables, when you're dividing, you subtract them. See, now that comes out to be a perfect square. And then sometimes it won't come out to be perfect. Let's try this one. I'm going to put it under 1. $500 divided by 10 would be 50. 3 minus negative 1 is 4. So then when I break down 50, I'm going to use 25 times 2 times x to the 4th. Well, square root of 25 is 5. The square root of x to the 4th is x to the 2nd. And then I still have that square root of 2 left over. So that's what happens if it's not a perfect square. The last concept is adding and subtracting fractions, radicals. And the thing you want to remember is, sorry about that, you want to remember that in order to add or subtract, the radicals have to be exactly the same. And this is what I mean. And you're only adding what's the coefficient. So we only add the 8 and the 10, and we get 18 radical 11. Now, if they are not the same, like this next problem, you have to simplify them so that they are. So I'm going to do a long one. So what I'm going to do is break down each radical, and if there's a number already in front of it, then you have to multiply it. And this is where you're just going to have to know your perfect squares and know your factors. So I know 54 is 9 and 6. I know 24 is 4 and 6. 19 is 16 times 6. And 63 is 9 times 7. So now you go through, and here the square root of 9 is 3, but there's a 3 already there. The square root of 4 is 2, but there's a 2 already there. The square root of 16 is 4. And the square root of 9 is 3, but there's a 4 already there. So when you simplify it, you get 9 square root of 6 minus 4 square root of 6 minus 4 square root of 6 plus 12 square root of 7. And you can only add the terms that have the same radical. So that's 9 minus 4 minus 4. 9 minus 8 will give us 1 square root of 6. And we can't add that last term. So that's your answer.